Coming back, part 2 of worksheet number 3, which is on two-step mole problems. Let's keep moving forward. So first of all, we always have to know where we're beginning. So for number 7, I've got 0.15 grams of C2H4. If I'm starting in grams, that means I'm starting at mass island. If I want to get to molecules, so that means I'm trying to end at particle island. That means I'm going to have to first go from mass to moles and then moles to particles. So keep that in mind, that our step 1 is going to be mass to moles, and then from moles I'm going to go to molecules, MC for molecules. So that's going to be a 2-step problem. So let's go ahead and work that out. And to do that, we're just going to follow our bridges. So you're always going to write down with what you have first. So I've got 0.500 grams of C2H4. Next, I'm going to take my very first step, going from mass to moles. To do that, I'm taking the top bridge, which means 1 mole over molar mass. So I'm going to put 1 mole of C2H4. And on the bottom, my molar mass, I'm going to put the grams of C2H4. Now I need to calculate what that mass is. So remember, I'm going to need 2 carbons and 4 hydrogens all added up. Each carbon is 12.01 grams according to my periodic table, and each hydrogen is 1.01 grams. So when I multiply and then add those all up, I end up getting about 28.06 grams for every mole. So that's what I'm going to put on the bottom, 28.06 grams for every mole. Now, in 1 step, that would be done, but we're not done yet, because now we're in mole island, we have to go to particle island. And to do that, since we're using this bottom bridge, we're going to use this conversion factor, which means we're going to multiply by Avogadro's number, 6.02 times 10 to the 23rd. And since we're dealing with looking at molecules, we're going to call those MCs, molecules of C2H4, this covalent compound. So we have that. We have to now put, of course, 1 mole of ethylene on the bottom. So 1 mole of C2H4. Now that we have that, we do have our entire problem set up. Let's make sure that the units actually cancel out. Grams of ethylene, moles of ethylene, moles of ethylene. We're left with molecules of ethylene. So MC molecules of ethylene, C2H4. Now we just got to do our math. Remember, to do our math, we multiply by top, divide by bottom. So we're going to take 0.15 times 1 divided by 28.06 times 6.02 times 10 to the 23rd divided by 1. And when you throw that in your calculator, you end up getting about 3.22 times 10 to the 21st power. It is important, though, for you to make sure you put this entire problem in your calculator and see if you actually get the same number. Because a lot of people goof up on their calculator work and end up getting a different exponent. So you have to be careful about that. All right, but make sure that you check that, and you should be all good if you end up with that same number. Otherwise, you aren't putting it in your calculator correctly. But that was number 7. Here comes number 8, and it looks like we're starting with hydrogen peroxide in liters. Now again, this says that it's a gas at STP. No, unfortunately that's an error in the worksheet, because hydrogen peroxide wouldn't be a gas at STP most likely. We're going to follow along with it and go with it. So for the hydrogen peroxide, here's the liters for it. So if we're starting in liters, we're starting in volume. A lot of people say, well, how am I supposed to know that volume is in liters? Well, you could look it up, Google it, or just notice that in the conversion factors, there's already liters right there. So just use your context clues. They're all right there, and the information's right in front of you. All right, let's keep moving forward then. We're going to go from liters to grams. So to get to grams, we know we have to end in mass island. So if I'm going to take this path, I got to first stop at mole island and then go to mass island. So that's going to be 2 steps. I'm going to go from volume island to mole island over to mass island. And again, that's going to be 2 steps to get there. So let's do it. As always, we're going to write out what we're given first, which is liters of hydrogen peroxide. Next up, we are then going to take our first step, which is going from volume island to mole island, which means we're going to use this conversion factor. I'm going to put 1 mole on top of the hydrogen peroxide, and it says to put 22.4 liters of hydrogen peroxide on the bottom. Why does it say that? Well, remember, for every 1 mole of hydrogen peroxide, if it's a gas at STP, that's how much volume it takes up. So those conversion factors are true. Now that we're doing that, if we're going to go from mole to mass, fair enough, we need to use this bottom conversion factor. So it says to put 1 mole on the bottom, so I'm going to do that, 1 mole of H2O2. And up on top it says to use molar mass. So I know I'm going to need grams of hydrogen peroxide. I just don't know how much yet because I've got to find the molar mass. So we know there's going to be 2 hydrogens and there's going to be 2 oxygens, right? Each hydrogen is 1.01 gram. Each oxygen is about 16 grams according to my periodic table. So add that both up, 2.02 plus 32, I believe is 34.04 grams for every, incorrect, 32.02, getting excited ahead of myself there, sorry. 32.02 grams per mole when I add that up off the periodic table. Woo, and I'm having trouble talking. Let me say that again, 34.02. Sorry, my words are not working with what I'm seeing. But anyways, now that we have the molar mass we got from the periodic table, we're ready to do our math. Let's double check to make sure our units cancel to make sure we're doing our math right. Liters of peroxide, gone. Moles of peroxide, gone, and we're left in grams. Did we want to be in grams? Yes. So this looks like, as far as units are concerned, we set up our problem properly. Please remember that we always start with the first number we have, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. So you're going to plug all of that into your calculator, and once you do, you should come out with a pretty straightforward answer of 8.3 grams of peroxide. So what does that mean? That means if you had almost 5.5 liters of this stuff as a gas, it would have a mass of 8.3 grams, all right? So you're just converting, saying, hey, I know there's this much, it takes up this much space, but how much mass does it have? We can use the mole map to convert back and forth between that. Again, that could be helpful for a corporation or a company. If they're going to be storing things, they need to know how heavy things are to make sure their containers can withstand the weight of it and that. So think about all those things that can play into effect when you have like a factory or some type of engineering feat. It's good to be able to convert back and forth. Plus, we'll be able to use that to start predicting chemical reactions and figuring out, hey, how much did we start with? How much will we end with? But let's keep moving on to number 9. Coming at you, number 9. Woo! We got 582 million molecules of carbon dioxide. So notice, even though it says it's a gas at STP, it says molecules. So we're using particles, and we want to eventually get to grams. So if you think about it, 582 million molecules of CO2, that sounds like a lot, but I bet that's not going to be that much in mass. So I'm going to go from particle island to mole island, and then mole island to mass island. It's going to be 2 steps. Well, let's do it. We know that we have to write out, of course, the number we have to start with, which is 582 million molecules of CO2. I'm then going to need 2 steps, right? Because I just figured that out. Step 1, go over to moles. You have to know where you're headed. It says to put 1 mole on top according to the conversion factor, so that's what I did. It says to put Avogadro's number on the bottom, 6.02 times 10 to the 23rd on the bottom. We're talking about molecules, so that's what I have to label it as, molecules of CO2. Check. Now I'm going to go from moles to mass. To do that, I'm going to use this conversion factor. It says to put 1 mole on the bottom, so I'm going to do that. Up top is molar mass, so I'm going to put the mass of carbon dioxide up top. Now, by now, you're expected to know how to find the molar mass. Just look on the periodic table. 1 carbon plus 2 oxygens. Add that up, and it's about 44.01 grams for every mole. Now that we've set that up, let's double check our work. Molecules of carbon dioxide cancel. Moles of carbon dioxide cancel. We're left with grams, and that's what we were trying to solve for. So the good news is our problem is set up for success. We're going to end up with the proper units, so I'm going to put that for my answer, grams of CO2. Next step then is to do the math. Always put in the calculator what you have first. Multiply by the top, divide by the bottom. Multiply by the top, divide by the bottom. So throw that all into your calculator. And when you crunch out those numbers, you end up getting a ridiculously small number. You get 4.25, but get this, times 10 to the negative 14th. It's nowhere near a gram. So even with 582 million molecules of carbon dioxide, it's nowhere near a gram. Remember, to the negative 14th means that you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way 14 places back in the decimal point. Think of how many zeros that is. That's like 13 zeros, right? That's incredibly small for mass. So even with millions and millions of molecules, you can see how ridiculously small and light molecules are. But anyways, that ended up being your answer. 4.25 times 10 to the negative 14th grams of carbon dioxide, even with 582 million molecules of it. Incredible. All right, number 10, we've got 3 liters of tin fluoride. Yikes. And this is another error because tin fluoride technically wouldn't be a gas at STP. My apologies for the incorrect reality of it. But in the end, you're in liters, so you're in volume. So let's at least practice the steps, even though this isn't like something that would really happen in nature. Sorry about these little typos here. I'm just noticing. All right, we would be going to mass, right, because of grams. So that means I'm going to go to mole island and then mass island, right? We know that volume is always in liters, mass is in grams. So this is nothing new to us. Let's take the 2 steps. So first thing is 3 liters of tin chloride, and I'm going to convert that to moles, which means I'm going to put 1 mole up on top like the conversion factor says. And I'm going to put 22.4 liters of tin chloride on the bottom. Again, this normally wouldn't be a gas, but we're going to go through the steps just to practice them. But again, this in reality, tin chloride wouldn't be a gas. Sorry about these typos. All right, we're going to go to mole island to mass island, which means we're going to use molar mass and over 1 mole. So I'll put the easy one first, 1 mole over 1 mole tin chloride on the bottom. Up top is going to be my molar mass. To find the molar mass, you're going to add up 1 tin plus 4 chlorines off the periodic table. I expect you to be able to do that by now since we're doing 2 steps. So when I added all that up, I got about 260.5 grams. As always, let's double check. Liters of tin chloride gone. Moles of tin chloride gone. Tin chloride, technically. And I'm left with grams of tin chloride, which is what I wanted. Good. That means that at least my work units are set up properly. Let's do our math. To do that, you know the drill. You've got to take the number you started with, put it in the calculator, multiply top, divide by bottom, multiply by top, divide by the bottom. Throw those in your calculator, and what do we end up getting? About 34.89 grams of tin chloride. If this really could be turned, from a gas into, at STP, which is impossible. But in the end, we're still practicing our actual conversions, which is great. Can you use the mole map? By now, you should be able to. We already did 1 step. Now we're on to 2 steps. So it's just adding 1 extra step to it. Nothing overwhelming, but then again, if you struggled with 1 steps, this could definitely be a little bit of a headache for you. But in the end, we went through all the rest of our problems for worksheet number 3, 2-step moles. Of course, reach out to me if you need further help. We can go through them together or that. And the beautiful thing about videos is, of course, you can pause, rewind, re-listen, think about where that number came from. That also can help you as well. But take care, Science fam. Keep on crushing it.